Welcome everybody to our webinar. My name is Marcel Müller. I'm a German entrepreneur and consultant. I have a PhD in business process management here in Germany on a topic related to decentralized systems a couple of years ago. But I've been doing AI in projects since 2014. Back then, AI was quite a little bit different. There was no generative AI in 2014. But 2014 was the time where people figured out how to use graphics cards for deep learning, and that kicked start a lot of the developments that we see the benefits of today. I worked across half of the German big industry and in academia across different places in this world. And my core expertise lies in blockchain, in AI, and in specifically from the picture or from the viewpoint of business process management and how we make our business processes better with a new innovation. Um, I do work with hands-on AI projects on a day-by-day basis. So you not only get here a lot of academic knowledge, but you will also receive here quite a lot of insights that I have in my day-to-day work with real-life customers, building real-life applications that we do. Apart from my work with the Center for Deep Tech Innovation, the Center for Deep Tech Innovation, which I'm part of, is a collection of different, experts in different deep tech fields, usually PhD level experts, plus developers and data scientists working on delivering innovation projects. So not only me, but a whole team that is standing behind and building things. The core competencies are AI, but also blockchain. We have colleagues, not me personally, but we have other colleagues that are focusing on climate technology and especially climate technology and IoT. And what we do is we help with different consulting services and building applications, especially with AI lately, along the way. Something that I also will tell you again in the background, we also do training, a little bit more in-depth training, what we call the AI 432-100 training and jumpstart program, where in 4 weeks we will educate 3 people of your organization in 2 sessions per week how to optimize business processes with AI and get you from 0 to 100. We will send out the slides later, and you can also see about that. And you have here already my Calendly link if you are interested and you would like to talk after this webinar a little bit more. And also at this point, it's also worth mentioning that, as said, I work on day-to-day projects with generative AI, with applications from the start to the end, with my team and with our own low-code platform to create applications called Engine. I'm depending on how many questions we have today, I might show you a little bit of our work later, but you are all here for the meat on the bone, and let's get started. By the way, if you have any questions, I am doing my best to have a look on my second screen. So if you see me having my weird eye looking to the left, I'm looking in the chat. If there's any questions, feel free to say so. I have my lovely assistant Emilia with me, who will also try to help and answer questions and get you up to speed. This meeting is also recorded, so if you need to leave earlier or if you want to give it afterwards to your colleagues, we will send you an email with the link afterwards after it's going to be uploaded on YouTube. Without any further ado, let's dive into the topics. And what I would like to do today, I would like to quickly recap a little bit on our way on generative AI and how we got here. And then I would like to talk about challenges that especially companies or larger scale enterprises have with generative AI. And then in the last part, I will dive a little bit deeper into components of enterprise generative AI, which is quite a little bit something different than using a chat interface and chatting with a chatbot and calling it a day. So it's a gradual step into the topic. And when we think about how we got here, is that generative AI had really its breakout moment in the late 2022 with making ChatGPT publicly available. Um, ChatGPT is a application that has a chat interface on top of what we call today a large language model, and in 2022 there was also the large language model called GPT 3.5. Whereas GPT stands for Generative Pre-trained Transformer. That's the technical components of how this model is built. It's a transformer model. We have other webinars where I explain deeper what the transformer model is and what the diffusion models are. That's, I think, for today a little bit too much. But just that you know where this term comes from. But the chat interface and the model under it are two separate things, and they can be used in different things. Just for you, maybe to keep at the back of your head, because it will be much more important later on when we are going to talk a little bit deeper about enterprise use cases. And what this ChatGPT moment for generative AI really was, it was an eye-opener, and it was an incredible lowering of the entry barrier to AI and to generative AI, because honestly, everybody who has used some sort of chat interface before, let it be WhatsApp, Messenger, TikTok, or whatever, knows how to use this interface. Because it's literally nothing but a line where you need to write something and you will get something out. No matter how bad your prompt is that you write in, no matter how bad your spelling and your grammar is, no matter what languages you can speak, you will always get something out. Yeah, with emphasis on something. Not talking about quality at this moment, but you will always get something out. So I had, after this in the very first half year where people started to discover, especially ChatGPT as an application, I saw a lot of people that started dreaming about how they could use such an application in their business, and they could generate reports and questionnaires and all of the things related to their business with such a chat interface, which is good because it allows you to dream, and it allows us from an innovator's perspective to see what opportunities might be there. But on the other hand, we have also a lot of, let's say, strategists that are looking deeper into how actually this change with generative AI and with what it means for industries. We have here an estimate by Goldman Sachs that was published, I think, over a year ago, where they see on the x-axis you see different industries, and on the y-axis you see a percentage. And 100%, you can think of the 100% here as 100% is all of the task that at the moment a certain business in that industry does. And with this color, you see how much of this work that typical businesses in this industry do will see 0 to 10%, so almost no automation here in dark blue, especially for, let's say, physical activities, building, maintenance, construction work, installation, and repair, and production, where you see there's not really a lot of AI automation happening. But on the other hand, you see also businesses where a lot of the activities and the tasks of work that we have in that industry will at least see some sort of AI complement. So either an AI companion, a chatbot, or some sort of integrated system that works alongside a human to speed up the process, so to speak. We see that a lot in computer science already, everything that is with computer programming, maths, but also here business, financial operations, community social services, education, a lot in education, and a lot in sales and engineering. And then we see certain industries where there is let's say a decent size of the activities in that industry that can be more than 150% automated, so likely replace current manual work with an AI in an automated scene. And you see that especially in office and administration support and in legal. Um, Legal is interestingly one of the verticals that I work a lot in. So I work with different lawyers on automating, let's say, class action lawsuits, in everything that is typical large volume casework. Has quite a lot of potential in there. Apart from that, I've also a lot of customer support, a lot of report writing, a lot of procurement and other things, but I will talk about that later a little bit more in detail. But so that you just can now look a little bit for your industry and see not what I am saying, but what Goldman Sachs is saying, what the potential or is, and what the potential impact of an AI to business might be. So that's the dream. We have the dream before we can do something with the ChatGPT, and we have the strategy. Some strategy consultants giving us the lead that it's going over on and how we could do that. But the real question is, we are companies. We are not consumers that do play virtual tic-tac-toe with a chat interface, but we are enterprises that have specific challenges. And what I have seen by working with mid-sized companies to large scale companies is always three different classes of main challenges. One of them being scaling and reproducibility, the second one compliance and privacy, and the third one data and systems integration. That being said, scaling and reproducibility. So I said in the beginning, anyone who can use a messaging app can also use ChatGPT. But that doesn't mean that you get actually enterprise quality or enterprise grade quality out of it. A lot of it has to do with writing the right prompts in the right way, but also ingesting the right data, having the right processes, because actually there's only very few use cases where you can just put everything in a single prompt. Mostly it's processes and it's sequences of different prompts to each other, and that's quite something different. And that there needs to be and you need to have some skills in prompt engineering and in AI application building to make something that is actually reproducible and scalable. And with scalable, in most of the cases, you can upskill your whole organization to know how to do prompt engineering. But think about it, you are a company that does customer support and you have 100 customer support agents, and you want to use a generative AI for 100 customer support agents that helps creating answers. So you have 100 people that all prompt a little bit differently, that have different styles. So automatically you have variation in your answers, and that's something that you rather would not like to have on a long way. And that's the first challenge. The second one is compliance and privacy. You may or may not have the challenge that you would like to work with private data or with personally identifiable data, especially here in the EU and within a certain compliance framework. If you're in a highly regulated industry, I work a lot with the finance industry at the moment, which has after healthcare probably the highest amount of regulation that it needs to adhere to, at least here in the EU. Where some patterns of using a third-party server that might be in a complete different jurisdiction might be a problem. There are solutions for that. For example, there are right now also AI models that are not ChatGPT, but that are doing similar things to other large language models like ChatGPT. For example, like Llama 3, that you can have completely on your own premises because they are open source or openly accessible. Or there is some halfway in between solutions like OpenAI. You can also get it if you're a Microsoft Azure customer in your private Azure tenant as a completely isolated way. So there's nuances of where these models live and where they go, and what you can do with it. And the third one is data and systems integrations. That's the third biggest challenge. Or the third of the three big challenges. There's no order to them. So ChatGPT doesn't know your internals of your company, and for good reason, because this is private data. But there is a lot of value to be gained if you could have access with a large language model to your company knowledge. So I always say, think about if you have been working in your company for a year or two, there's always that one person that has been working there for the last 15, 20 years, and that person where with a good memory where everybody goes through when they have a question they can't answer and they don't know where to find the answer through. And giving a large language model access to that type of company knowledge that resides in the head of people, but in real life it doesn't only reside in the heads of people, but across many different Word docs, PDF, databases, Excel sheets across your whole company in an unstructured way, and giving or structured or unstructured way, and giving your AI-powered applications access to these pieces of company knowledge can create a lot of value. For example, I have a lawyer right now who's working with cases, case-based insurance cases, and they have about 20,000 cases each year, and they have also their company knowledge is basically all of their previous cases. And if they create a new case, or if they have a new inquiry for a new case, they mostly look up in the things that they have been doing in other cases before. But finding that and getting that into a workflow is not so easy. There's ways on how to do that, and we will today look a little bit deeper into them. And there's also the systems integration, not only the data integration part, but the systems integration part of it. When you are in a larger scale corporate, you have usually a landscape, I call it a zoo of different IT infrastructure that you have to use or that you have to adhere to. Also a lot of corporate governance, authentication, authorization, role, and group management, where all of your business processes in an organization have to adhere to. And getting a large language model powered application into that governance setup is for production sometimes also challenging. And with that, with these challenges, we created our reference architecture for how enterprise generative AI applications should look like in terms of architecture. And we have several different layers. On the bottom is the hardware layer. Above the hardware is the model layer. Then we have the orchestration layer connecting the model layer and the data layer to the application layer. And the application layer is the very top with our application logic. We are going to go through these all step by step in the next things. So hardware. Large language models need to be trained on data, and training these large language models on data is pretty expensive. So there was for GPT-4, I think it was something just in Microsoft Azure credits. We talked here about I believe $6 million or so that were used just to train this model, only in hardware costs, not even talking about the personal cost, the people that you have there, and the know-how that you need to have in your organization. Once an LLM is trained, we generate an output. So when you put in a prompt, you generate an output, and we call these things prompt completions, because we are completing a request based on what a large language model is coming up to. And also it's not as expensive as training, but it's more expensive than making just a lookup in a database. And when we build the applications in enterprise, we have to keep that in mind. When we evaluate a model, we are usually by 2 orders of magnitude more expensive than doing easy non-AI related retrieval tasks or calculation tasks. So hardware is one of the way where everything lives. Then, of course, you need the hardware to train and to execute models. Probably in most of the cases, you don't train your own models, but you use what we call AI model as a service. This is a commonly used pattern where you use a pre-trained model from somebody else, like OpenAI with GPT-4o now, and you make a call to this API with your data and your prompt, and you get the answer out of that. In that way, you have, in terms of data governance, you have a pretty simple setup. You have somebody sitting there, writing a prompt and ingesting that data into a prompt, or with an integration via an API, so that no one is sitting there anymore and writing the prompt, but it's actually automated. And then all of the data is being sent to a third-party server. In the case of OpenAI, that's a third-party server. I just saw a message. Yes, we are going to provide the slide deck and the recording. So Brett, don't worry. We are going to send it to you probably latest by Friday. So check your inbox. Just because I saw it. So sorry. Continuing in the text, we have a second option. We have an on-premise. We have the option to use on-premise pre-trained models. In that way, we wouldn't transfer any data to a third party, but we would have to manage and orchestrate that model on in our premises. One example, there is like dozens of very good large language models that are coming step by step closer to the let's say to the capabilities of a GPT-4 or of a GPT-4o, namely the model from Llama 3, that's from Meta, from Facebook's parent company, is pretty good, and that can be deployed completely there. But there's others out of Alpha. There is others Falcon models that you can execute and have as a real copy in your own environment. For very highly sensitive data, I don't know what exactly your business is, depending on what it is, that might be an option. Or you can always train your own model from scratch. But in most of the cases, I disencourage that, because unless you are Google or unless you are a big company that is doing something that is so novel and so not universal, where you need to have something very specific. What we can do in addition is we can use a pre-trained model, and we can fine-tune that model for a specific application. It's quite expensive if you compare it to the other level that we are going to talk later about, Retrieval Augmented Generation, but is doable and not too much. So I recommend fine-tuning in cases where you need to train a model to respond in a certain voice. Yeah, where for example, if you are IKEA, IKEA always greets you with the term "hey," but written H-E-Y, no H-I-H-E-J, and because that's the Swedish version, and you want that your model speaks your corporate speech, then fine-tuning is probably a good way to go. But in the end, if you want to have precise retrieval of information with a source, fine-tuning won't help you, because fine-tuning is like the normal, like the base foundation model, just a statistical interference of how likely a certain word comes next as an answer to your question. So it's a stochastic model, and also fine-tuning is stochastic. And if you want to have something that's a little bit more precise, and where you can actually trace back where it comes from, you need to go for Retrieval Augmented Generation, which we are going to be talking about in a second. If you are going for these type of on-premise models, you have overhead, what we call these days AI model ops. If you have that, or if you are using a third-party system, you need to monitor your costs, because these things are not so cheap, and especially if you are looking to scale, you have to monitor these costs, and you have also to estimate, your prompts and what on average they are going to do. So there are different models that have different prices. So I always tell my people that they should think about these AI models a little bit like a commodity market. Because they have the same, like if you take a typical commodity market like oil, they have the same properties. Fungible, like similar to oil barrels. So if you have two oil barrels of the make Brent oil, or if you have American fracking oil, they have a similar quality. They are and they are consistent, never mind from which supplier you get them. With with large language models, of course, we have different models. They are all better or worse in certain areas, but you have at least classes that you can compare to each other in terms of quality. So things that have different similar or near similar quality attributes, like if you have a GPT 3.5 class models, there's like 20 different models out there, also open source models that are as good as GPT 3.5, then you can interchange them. You have market dynamics like oil. API calls are influenced by supply and demand. And the supply and demand at the moment, or at least the supply is being dictated by the GPU availability on this planet. So at the moment, I think last week, NVIDIA has become the most valuable company on the planet. Or at least, no, not yet, but they are at least more valuable than all of the German publicly traded companies at the stock exchange together. I think that was what I read last year and last week. And these type of chip manufacturers, of course, they have an upper capacity. And also when you think about the supply and where these chips are currently manufactured, mostly in China and especially in Taiwan. And when you think about the current geopolitical situation over there, and you think a little bit long term, situations that might happen or might not happen, might come to a certain shortage that limits then the supply, and that will drive up prices in the meantime. So that's something just to be aware of. Yeah? We talked about homogeneity, and we talked about that LLM completions are fundamental products or like raw materials to build actual applications on top of it. Analogous to oil's role in creating plastics and petroleum and other products. And half of what we have in our world today is somewhat related to oil and to plastics. So just for you in that mind, yeah, it might be a little bit of a stretch on the first thought, but for me, model executions can be seen a little bit like a commodity market. Once we have made our choice on where we are putting our AI models, which models we are going to choose for, we have to feed our data in our application. We have to feed our model with data in our applications. And we have two different types of data. We have case-specific data and we have case-independent data. So let's say you would like to create an application that automatically answers customer support requests via mail. The question that a customer has, that's case-specific input data, because that changes from case to case. Yeah? You might have two customers that ask them something that is kind of similar, but per case, it is usually a different questions. And then you have case-independent data. And that's something like a knowledge base, because your knowledge base isn't changing whether or depending on what question you get, but you just have to find different parts of that from that knowledge base and use different parts of that knowledge base to answer certain questions that you have from your data. And think about these as two very important different classes of input data. And for case-independent data, we can use a pattern called Retrieval Augmented Generation. With Retrieval Augmented Generation, I can go quite deep on how that works, but for you it's important. Think about Retrieval Augmented Generation. You have a database with a lot of knowledge in, and you can query this knowledge with semantic queries. So with queries where you say specifically in the natural text what you are looking for and what you want and what you need. In that case, Yeah, think of it in that area a little bit like a search engine, but on steroids. How that works in the background, again, I can also give you a 2-hour lecture on how actually embeddings and retrieval augmented generation with vector databases work. But you see here, when we create an embedding, we are encoding the semantics of a piece of text together. What do I mean with semantics? Well, each of these words in a sentence, they have a relationship to each other, and together they make what we use to understand what it says. So I want says I, and that's the verb. I have a verb, and the object of that verb is um, to eat and pizza. And what do you want to eat? So the objective of that thing is pizza. So there is a relationship between these words, and that's what we call semantics. With what we had in, or what most of the companies have right now with keyword-based search, we can search large amounts of data if we are looking for the exact word that we are looking for. For example, if you are looking for chair, you will, with keyword search, you will only find text or records in your database that actually have the word chair in it. Maybe case sensitive, maybe not, but chair. If you are looking for keyword search and you are looking for the term seat, you will, but in your database, there is not once the term seat coming up, but only the term chair. You will never have a hit, because a keyword search doesn't understand that the seat is just a special type, or is related at least to a chair. Semantic search, where you have a database that was encoded with embeddings, your search does understand these things, and you will get concepts that are semantically similar to the meaning that you have been put into. And in that way, this is a huge game changer that we hadn't had before. That lets you now query very specific in a natural language for very specific excerpts of data of context that you can use in your queries. And that, the structure behind that is, so you need to have your knowledge base, you need to have that, mostly a large amount of data, and you create an embedding with that is using also a large language model, or actually an embedding model. This data is then being inserted in that numeric form into a vector database. When you have a prompt with retrieval augmented generation, we take this prompt and we do what we call similarity search. So we are looking for relevant pieces of text in that vector base that are semantically similar to our query that we have. We retrieve the vectors of that data and we reconstruct the clear text. And then we put these text chunks into a large language model and execute your query. So, for example, if you are asking for, according to the Corman book of algorithms, how does dynamic programming work? So Corman is a big book. If you have ever done any kind of undergrad studies in computer science, you will probably have heard of that, because that's the standard book for algorithms, and that has, I believe, 900 pages. So it's a lot. Then we would like to search something in that book. We are ingesting that book. We are vectorizing it so that we have it in this database. Then we will ask our question. We will look for the page or the paragraph in that book that is most relevant to our question. That's what our vector search and our semantic search does. We will take that excerpt and then we will put it into a large language model that actually formulates then the answer based on the context that we just retrieved. And that's the whole principle of retrieval augmented generation. Then it comes to, before we go on the application level. So on the application level, you can have, of course, a chat interface, but you can also just embed these applications or integrate these applications into your existing IT processes and workflows that you have. And therefore, you need a middleware layer that I call orchestration. Orchestration is taking your application logic, is translating it to certain queries, is getting the data from the database, and is executing a series of prompts or a process of different prompts from with a large language model, is taking it and is giving it into the right format in an application. And that's what the orchestration layer does. And this is, for me, this is the standard reference if you want to go for actual enterprise-grade applications. Yes, there are the Microsoft Copilots of this world, but also the Microsoft Copilot at least implements some parts of that. So if you have the Copilot for Microsoft Word, they do basically retrieval augmented generation with the text that you have. But the real part is building these applications in a very, let's say, in a very low friction way, so that you have processes that can be used end to end in a high quality. And that's what my company has been building in the last couple of months, and since last year, beginning of last year, which is Engine, an enterprise AI engine, so a business process engine with a low-code application builder. So it's not an application builder where like Appian or like Zapier, but it's more of an workflow engine where you can create specifically retrieval augmented generation workflows, fine-tuning workflows, different models, different inputs, and different data integrations to your processes. And I can show that to you in a second, that you have a little bit of a feeling how that looks like. So I have here an application that also this is End Engine. You see, you have different applications. I have like 60 different applications over here, and we can select an application and we can build an application. And what I can tell you right now in enterprise, there is basically 4 different archetypes in which you can classify 95% of all enterprise generative AI application into. One is you use a large language model in a process automation as an application. The second is you have your own company guru type chatbot where you are integrating different knowledge bases, and you have basically your own company Google. The third one is an actual chat agent, and the third application, the fourth application is using a large language model while you are working on a certain document as a companion or as a dynamic templating engine. That's the 4 different types of applications that I see right now in the industry. There might for generative AI or 95% of everything that I see. I have here an application that is called VC Companion, and I will show you how that application looks like. In that application, you have different processes that you use and that you want to. And I have here, so VC Companion is an application that I built for a venture capitalist, and that venture capitalist has the challenge that they would like to analyze the pitch decks that they are getting from founders that want investment automatically, because they have 1,500 pitch decks every year, and it's quite tedious. So the overall application is supporting to make the decision on whether or not to go further with a certain startup, and based on that, you have many processes and sub-processes that you need to execute. And one of these processes is what we call the founder match analysis in the seed stage. The founder match analysis, what you see here is we have a process that consists of 3 different steps, and actually 4 different steps, and each of these steps uses a large language model. In this case, this is GPT 3.5, and 1 or more prompts, and executes it. We have here on the right side, we have our case specific data. So when we say each startup is a case, we have here our case specific data that always changes. And what always changes for every startup is the descriptions and the names of the founders and the startup name. And in my first prompt, which is here really just a template of a prompt, I say I have the following team composition for my startup called startup name. And this is a template that will be filled for each case. And I have the following founders with name and description. And then I have here, this is context information that we could also retrieve with Retrieval Augmented Generation from somewhere, where I say how a good founders team looks like. You always should have a CEO who's a little bit of a dreamer, an engineer who can build something, and a CSO who can sell something, who has the hustle attitude. And then I say, describe how good these founders match this ideal, and add X out of 10 how good this is. We can use different models in here. So we can use GPT-3, we can use GPT-4, but we can also use open source models like Mistral or Mixtral, or GPT-4 Turbo with Vision, that we can use in here, and depending on also our compliance criteria. For example, we have also in this platform, we have also the opportunity that you have your own models, so that you can actually use it in your own, either your own Azure subscription or really on your own data center if you have that, so that data never leaves the company and you can really work with internal workflows. Yeah? And with Microsoft and Copilot, that's quite nice, but Microsoft requires you that you have only access to the data that you have in the Microsoft 360 cloud. We let you use any type of data from any source that you would like. And you can add more of these models here by dragging and dropping. For example, if you would like to use Retrieval Augmented Generation, you can just drag and drop a vector store over here and a vector store retrieval template, and then you can build with this thing very, very intricate processes that are very specific, and chain them together to make something. In this example that I have here, the example that I gave has a second step where we say, okay, I have here again my startup team, and now tell me how well this the startup is composed with respect to gender balance. The third step in this process tells you how to is analyzing that certain things are suited, or certain founders are suited based on their past experience, and that in the number between 0 and 10. In the end, you are kind of collecting all of these things together, and you are creating one single answer. And each of these steps here is a separate execution that does in work separately. And what we have done here with that platform is that we can use this graphical interface to build an application where the end user doesn't have to worry about any prompts, any data sources, or anything. They just have to fill out their data that is related to that case, and then press execute it. And what happens now in the background is that this process that you have seen is being orchestrated. It's being compiled, and in the end, after a couple of seconds, we get an answer. And the answer is here that this team is an 8.67 out of 10. That's the aggregate score. So we don't see the intermediate scores, but we only get the last one. And that's how we build applications. Yeah, this platform can do many more things. We can also have you inputs, not only text, but also files, URLs. We can do OCR. We can do options, and we can do many other things. And what we do is we take this type of this methodology. We look into the actual processes that companies have, and we build something very specific. And in most cases, it's something more than just a chatbot. And yeah, with that, I would like to close for today, and leave up the round for questions. With again the prompt to you. This is my LinkedIn. And if you are at the moment in the process where you are trying to get your hands on AI, or you want to have something implemented or in AI, or you want to train your people on building applications like I've just shown you, just scan this QR code or go to that Calendly link and feel free to book a session with me. And then I would like to look into the room and see if there are any questions. Yeah, Bob, yeah, what you summarize, basically, yeah, we can use internal company knowledge, and we can summarize them with a large language model if they want to. But you know, it's a very superficial framing. It's more about processes and using these things in processes than summarizing, right? It's not about the summarization. It's about having access to them and using them in processes rather than about summarization. You can do summarization, but I think that's not the main challenge that you have.
Yeah, but if you use the information in context, we were using for a very, very large idea management system that was very secure, and to be able to summarize each idea so that now you had something to use for auto association between all of the different ideas and many other elements. It really added a automated capability now that
Mm-hmm.
humans then have to go in and curate, because you can't just allow it to free flow associate. But
Oh yeah.
once you get that then connected, it gives you something really to move off of, to use for ontology management, for creation of something that's very sophisticated.
Absolutely. I would more call that, yeah, pre-processing. If that's summarization is a part of it, but there's also a lot of transformation including in it. So summarization is a part, but not the whole picture. Yeah, and the question with all of that, it's the semantic web approach with ontologies and all of the concepts and RDFs and everything that you have behind it. Yeah, there's right now a debate. Of course, you can use a large language model to create you an ontology for knowledge management, but right now there's a big debate if ontologies are actually needed for most of the knowledge-based work that you have. I don't have a particular opinion on that. I think ontologies are very overhead heavy and very and need a lot of maintenance and pre-processing until you can create an ontology. But if that's for knowledge management, the long-term way to go, I can't tell you at this moment. There's also a debate in the space for that. At the moment, I have people that ask always for ontologies, but then in the end, they realize the thing that they want is actually retrieval augmented generation with maybe a little bit of fine tuning, which is even in that case more lightweight than retrieving an ontology.